All right, hello everybody. So today we're going to continue our discussion in Chapter 4, Section 2, and I'm just going to show you a couple more examples of what we began talking about in the last video, which is how to go about graphing a rational function. So let's get started. You can see here I have this rational function f of x equals x squared minus x minus 2, and in order to graph that, we will start by finding the vertical asymptote, the horizontal asymptote, if there's any holes, and then also the domain of this function. And in doing that, remember to find the vertical asymptote, we take the bottom and we set that equal to 0. So we would set x squared minus x minus 2 equal to 0. That will factor into x minus 2, x plus 1 equals 0, which gives us x equals 2 or negative 1. So you can see in this particular function, there will be two vertical asymptotes. Now, the next thing to find is the horizontal asymptotes. And the horizontal asymptotes are found by comparing the numerator and the denominator's degree. In this case, the degree of the numerator is 1, and the denominator, it is 2. So when the top is smaller than the bottom, we automatically just write y equals 0. Now, as far as holes go, holes happen when the numerator and the denominator have a common factor that cancels out. And in this case, there are none. So there is no common factor that cancels, therefore we write none. Now, the last thing we want to list is the domain of this function. And remember, the domain comes from two places. It comes from any vertical asymptotes you might have, as well as any holes that you might have. And it's a combination of those two. Now, you can see that we have two numbers, 2 and negative 1, that would need to be excluded from the domain. If I draw a picture of this, negative 1 would be right there and 2 would be right there. I can pick anything here, just not negative 1. Anything here, just not 2, and then anything there. So there are three distinct areas that need to be listed whenever we list the domain. So that first area would be negative infinity to negative 1, and then it would be union negative 1 to 2, and then union 2 to infinity, like that. So now that you have those three listed, we can begin to graph this. So what I'm going to do next is I am going to draw a coordinate plane. And followed by drawing a coordinate plane, I will put my hash marks on. The hash marks, 4 are probably enough. If we need more, we can always add more. Then we are going to proceed to draw in our horizontal and vertical asymptotes. So as we figured out, this will have an asymptote right down through 2. And it will have an asymptote right down through negative 1, like that. And we do have a horizontal asymptote right at y equals 0, which is on the x-axis. Okay, so you can see that there are actually three distinct areas in our domain. There's a chunk here, a chunk here, and a chunk here. And you can also see that from the domain itself when we write the domain. Now, that part matters because whenever we go to make our tables, however many parts we have left to right or in the domain, however many of these that we have, that is how many tables that we need to make. So we need to make a table within each of those three areas that the two vertical asymptotes create. So I'm going to make a table, an XY chart right here, and then I'm going to make one right here, and then I'm also going to make one right here. So you can see there are three distinct areas. So I am writing three different tables down. Now, what we need to do is we need to come up with x values for each of those tables. And your x values are going to be based on where those asymptotes are. You can see this asymptote crosses right at 2. So for the table that is in the right-hand section, we are going to pick numbers greater than 2. So in this case, 3, 4, and 5, and that's plenty. Now for the middle table, we can see that the middle is bound by -1 right here and 2 right there. So we need to pick our numbers for the middle table in between those two. Well, there's only 2 numbers to pick in there, and that would be 0 and 1. Now the last table that we're going to pick will be to the left of this one highlighted right here. So that is at -1. So we want to pick numbers over in this section. So that would be like -2, -3, and -4. So -2, -3, -4, just like that. Now, the next thing that we need to do is we need to come up with our y values for our table. Now, there's quite a lot of y values here. And what you would do is you would take each one of these x values and plug it in for the equation to solve for your y value. Now, I am going to show you a little bit of a shortcut that will allow you to maybe do this a little bit faster and make these tables a little faster. And that is you can use your graphing calculator to fill out these tables. So the first thing we need to do is you need to type in the rational function that we have here. So x divided by x squared minus x minus 2. And once I have those in, I can go ahead and go second table and plug in the numbers that I need. Now in this case, I needed -4, -3, -2. And you can see those three values, -4, -3, -2, will get written right here. So this is -0.2. The -3 is -0.3, and then -4 is -0.2 again. I'm sorry, that last one was not -0.2. It should have been -0.5, like that. The next two values I need for my table are 0 and 1. So we will go ahead and type that in, 0 and 1. 0 gives me 0, and 1 gives me -0.5. -0.5. And then we got to go to 3, 4, and 5. So 3, 4, and 5. And we have 0.75, 0.4, and then 0.28. All right, so now that I have all those values, I can now go ahead and graph those. So we have -2, -0.5, which would be about there. We have -3, -0.3, and -4, -0.2. So you can see that graph is slowly getting closer and closer to this horizontal asymptote like this. And what's going to happen as it approaches this vertical asymptote, it's going to shoot down very quickly. So there's our first graph. The other side is going to look very similar. We have 3.75, then 4.4, and then 5.28. So this one also will go like this, and when it approaches the asymptote, it will shoot up in the air like that. Now, lastly, in the middle, we have this 0, and then we have one -0.5, which is right there. Now, what this would do is as this goes up like this and approaches this vertical asymptote, it's going to shoot up in the air. And as it approaches this right-hand asymptote, it's going to shoot down like that. And there you go. We have our graph of our rational function. So I have one more to show you, and we will do the same thing as we did last time. So we need to find the vertical asymptote, the horizontal asymptote, any holes, and then the domain. So I'm going to do this one a little bit quicker. I do always want to factor the numerator and the denominator first. So you can see this would become x minus 3 and then x plus 1. Now the reason why I did that is you can see there is a common factor of x minus 3 that will cancel out. So we're left with x plus 3 over x plus 1. Now that's going to create a hole. So let's talk about vertical asymptotes first. Vertical asymptotes occur where the bottom is 0. So in this case, that will be -1. Horizontal asymptotes are dependent on the degree of the numerator and denominator. In this case, the numerator is 1 and the denominator is 1. So we need to divide the lead coefficients, which are both 1. So that would be y equals 1 divided by 1, which is 1. Holes are created if we cancel any common factor out. And in this case, we did. X minus 3 was the common factor. So you set that equal to 0 and you get x equals 3. So there will be a hole in our graph at x equals 3. Now the last thing to list is the domain. And the domain is listed by any numbers that are excluded from the vertical asymptote and or the holes. So the domain would be -infinity to -1, union -1 to 3, union 3 to infinity. So now that I have all that information, I can go ahead and draw the coordinate plane here. And then I can put my hash marks on and create my tables. So we only have one vertical asymptote, and that vertical asymptote occurs at -1 right here. So there will only be two tables this time. There'll be an XY table over here, and there'll be an XY table over here. So we need to pick numbers that are smaller than -1, -2, -3, -4, and then bigger than -1, 0, 1, and 2. And we can go ahead and use our graphing calculator again to fill out this table. It makes it a lot easier to get our values. So in this case, we would have x plus 3 divided by x plus 1. And we can go ahead and go in. Oops, I don't want to graph it. I wanted to hit table, second table, and then get our values that we need, which we need -4, -3, -2, and then we need 0, 1, 2. So now we have those values. I can go ahead and fill out my table based on those values. So -4 is 0.3, 0, and -1. 0.3, 0, -1. And then 0 is 3, 2, and then 1.6. 3, 2, 1.6. All right, so now that we have those values, one other thing to keep in mind. There is a hole at 3. There's a hole. So you'll see that I need to include that. Now we just plot our points. So -2, -1 is right here. -3, 0 is right here. -4.3 is right there. Okay. Whoops, we forgot to include our horizontal asymptote at 1. Comes across right there. So now you can see as this graph would go down like this and come up, curve, and then flatten out up against that horizontal asymptote. Now on the right-hand side, we'd start at 0, 3. Then we would have 1, 2, and then 2, 1.6, and then 3, there would be a hole. So we literally draw a circle there. So this graph would go here and curve and approach the asymptote and shoot straight up. And then to the right of the hole, it would be very flat where the horizontal asymptote is. And that would be your graph of this rational function. So I hope that made sense. And as always, if you have any questions, feel free to email me. Have a great day.